This is a quick tutorial on the TransNEXT, which is the interoperable replacement device for the Transnet or EL805 MDS radio system. So the TransNEXT supports interoperability within the Transnet system for serial broadcast. In this quick demonstration, we're just going to review the ins and outs of the Transnet, its configuration. I'm going to show you a quick example, a poll just to show functionality and simple setup for the Transnet to get it operating in your Transnet system. I'll do future videos that might go more in detail on advanced configs and or storing forwards, or even the Ethernet IP payload function, which is supported on a full TransNEXT system. So let's begin. So the first thing you need to know is the Transnet system uses a built-in password that's located on the label on the back side of the Transnet radio. Once you have that entered in, you can log into the Transnet dashboard. This uses HTTPS for secure browsing, and the default IP address is 192.168.1.1. The overall boot time of the Transnet is pretty fast as far as getting to this page. Now, I will say logging into the TransNEXT is where you sort of hit a slight lag. So you'll notice compared to the TransNEXT, which did not have a web user interface and used a proprietary diagnostics port for communication to the management, we now actually have a web-based user interface. Now, the interface is really nifty. It's got a lot of great function and features. Just understand that the configuration of the TransNEXT is still very much like the Transnet. So, and I'm gonna show you that in a minute here. So you can see on this remote, which is talking to a Transnet access point. There's two TransNEXT remotes on this network, and it works very much the same way as the Transnet system. So you can see here, these are running the latest firmware, 108, and they're on a network address of 8282. So all my radios, including the access point, are using this network address, which is what's used to distinguish the network on a TransNEXT system. We do have some IP information, which the Ethernet port that I'm connected to. I believe over the air we are still very much doing serial broadcasts, and this is sort of proven by the fact that when I pull a remote, my COM port lights up on the remote that's not connected to anything. You can see here they've given us a lot of great information when it comes to RSSIs. You'll notice that I do have an alarm for VSRW, which is because I have an attenuator in line. So either it notices that, or potentially my attenuator is damaged from excessive usage. We now have Spectrum Analyzer, which is really nice. So it gives us a nice clean range of the 902.8 to 927 spectrum. We have an RX signal analyzer as well, and then even this payload analyzer. Overall, really good information, a lot of good details on this new dashboard. We have these top menus. Again, there's not really a lot to these. It's more of just like a visual. You can't really modify or edit any of these menus. They just sort of tell you. As far as the other actions, we're kind of still limited on this product. So you can see here we do have an active and inactive image capability for firmware. We do have reprogramming, so you can do an upload. So that's very nice compared to the manual efforts on the Transnet. And then we have reprogramming, which has a lot of different options, including a passive, which would be and slow over time if you have active data, reboot, and then different actual modes for that reprogramming, which include like using all available bandwidth and less. We have a logging page here, so this is really nice. So perhaps this is actually where we clear our alarms. Let's give this a shot here. So I'm going to go ahead and clear this page. Looks like I'm going to need to maybe refresh it to take the hit. Let's give this a try. We're kind of learning together on this video, everybody. I'm kind of also curious to see if it's going to log me out refreshing this browser or not. Yep, sure did. So let's get logged back in. All right, so we're back in. So let's just take a quick look at the configuration. So you can see here that to configure this TransNEXT, it's not quite like the Orbit or some of our predecessors, but it is sort of similar to the Transnet in the sense that a telnet connection, and you had to know your codes, so you would enter things like RSSI, mode, X address unit, things like that to program that unit. Those same sort of configs are built in, but they're at least displayed for us to manually modify. Now, I have not gone as far as actually trying to break this config to see what it would do. That will be something I look into in the future as far as, just like forgetting a bracket or a comma. I would imagine that it would give an error or, throw some sort of a fit. When it comes to the configuration, though, it's really just as simple as modifying display sets, right? So, for example, we can see here we have our default Ethernet IP, our default gateway route. Now, I have modified this, so the standard is 19200 baud. I've lowered mine to 9600, and it's just as simple as just sort of typing that in here and then hitting save. Parity 891. We have CTS, RTS, hold times. So there's a lot of these newer and older configurations are shown. And then in the manual on page 30 to 45, you can find sort of these commands and details as to what they do and what options they offer. Now, the only other real thing that we needed to set up for this to work was the network information. So you can see here we have our 8282 address, and really that was it. So to make this work in an existing system, we put the radio on the correct network address. It already has sort of a default unit address, so you may need to ensure that you're not conflicting here. It is set up for a remote, which is default. We're using 30 or 1 watt power by default. We've modified our network speed, which is our serial port speed, which is 9600, and that's really it. And I've made a couple other changes. I inverted the e-ink display on this unit. So black text is now white text, and the white background is now a black background. But other than that, this was really super simple to set up. And you can see here where the Ethernet, the IP payload is what that stands for, is an option here. So this would be a completely full TransNet system. So if you're doing one from scratch, this would be the way to go. This is going to operate similar to the SD's Ethernet over the air. The idea here is that these are long range system. So, we do basically serial payload or IP payload over the air to minimize the amount of overhead for that Ethernet traffic, and it keeps the robustness of the transit system kind of in place. So, overall, I mean, it's a great job. I'm really excited to see how the customers respond. This was so easy to set up. I have no issues, and in the future videos I'll do some of the Ethernet configs, the IP payload, things like that. But just remember, those are future options. Same for the radio 2 port. If you're just really trying to keep buying radios for your existing TransNet system, this is the way to go. And as always, I would recommend that you put this not only at new stations, but you try it at existing stations that maybe are having communication issues or don't have the best signals. The technology is newer, it's greater, so there's a really good chance that this will work better in place of a transnet. So you may find that just simply upgrading some of these stations that potentially have communication problems may benefit from the newer technology. And then there are other buffers, retries, store and forwards, forward error correction, and things on the radio that can be tuned to sort of add to those improvements. Let's do some quick polling and just kind of see, just so you can see sort of the proof of concept here. So right now I've just got a mod poll, device slave situation. We're just polling 9600, 891, and I'm just going to go ahead and run my my device and then go ahead and run my poll. You can see here we've got a nice poll going. So I'm going to show a picture on the screen of the actual remotes that I'm pulling through, and you can see the signal that we have is relatively good for this link. And yeah, this is it's a really nice product, and I can see the comm light flashing on my second remote. So again, this is very similar to the native software, a serial broadcast system in place. Now we are we are having some timeouts on these polls, so that that's kind of interesting. I'd be kind of curious to see in real time what we can do to potentially improve that. So let's see, I'm just going to kind of look here to see what kind of buffers we have access to, and if there's anything we can tweak on the radio to improve that. So we are doing 9600, 891. Not seeing a lot here, so let's see, we've got hop time is 7. All right, so it looks like one thing I've read in the manual is this RTU on off. This actually refers to the GE RTU simulator software. So this isn't anything to do with the actual Modbus RTU protocol, but instead, if you're using their polling simulator, this is where you would enable that. And then I would assume this is then the RTU ID for that as well. So the signal on the e-ink display is showing a minus 59, even with a 30 dB attenuator. Now I am 2 feet away from the access point, so I'm going to just try and change the power on this guy and just see what that does with some of these timeouts, and maybe interference issue here, right? Now it also could just be timing. So for example, if I cancel this and just maybe add a buffer in here, I'm sure that would help. I always like to see if I can make similar adjustments through the radio rather than through the polling. So if I put a timeout, let's see here, poll rate, maybe if I change it from 1,000 milliseconds to 1,000, it'll probably be a lot cleaner. Nope, not at all. So we still have, like a couple missed polls, even with this slower rate. So the power is lower. I'm gonna hit the button on the radio to refresh that e-ink. But then if I just go over here to my dashboard, I should be able to see those changes. So let's clear this. Okay, so now we can see that it did improve a little bit. 61. 62, so it's setting that power did help a little bit. I am in a test environment. My signals are probably kind of half good, half bad. My access point has an attenuator, so it could be like just a test environment situation. But there's not much else here. So if I had to guess, it's probably just a signal issue. Let's do this. Let's just keep going on these test parameters. I'm going to turn repeats off completely. Let's see if that makes it better or worse. I would almost assume probably worse. But at least at this point, basically, we're just gonna go, and if we don't go, we don't go. So, the real test here would be is like out of 100, what looks better. I think by default, it's not, it's always a good idea to have some retries, repeats in there, but sometimes efficiency, can play a role in the quality of the data in the messages. So I kind of forget what that number was. So this might be a good opportunity to see if there's a way to restore defaults. So we have actions, reboots. So we have our active image. It looks like we may have to use the CLI. So let's connect to PuTTY 192.168.1.1. We're going to log in as admin. We're going to type in our super secret password, and we're connected. So we have a number of options in the interface here. Okay. So that gives us our basic information. So password, looks like you have to do it from the CLI. So perhaps password, okay. Definitely have some latency from, let me see if it's the polling that's causing this. Oh yeah. So that's interesting. So the pulling this radio and connecting to the web GUI and doing SSH definitely does put a bit of a burden on the processor. So this is something to keep in mind. The TransNEXT is not an orbit. It's what we would call is our low power processing unit. And the idea is to maintain that compatibility, bring it into the real world, I guess you'd say the modern era, but also sort of keep it, at a price point and power point that, kind of makes all these things sort of mesh well. Admin. Let's see. Okay, so it failed because of the character restrictions that we did see in the profile. So if you're going to change the login password for the orbit, then you're best to basically remove these restrictions that are set in the orbit's config, and then do an SSH into the orbit to change your password. To wrap this up, I just kind of wanted to review the TransNEXT manual and a little bit more about the platform. So be aware that the TransNEXT is being released in stages. So not everything that's in the manual is necessarily available currently. And that mostly applies to the build. So you're going to see here, we do have a couple different build options. As of right now, we have the with and without e-ink display. So this is the really cool interface or visual kind of e-ink display on the actual TransNEXT that gives you sort of your radio configuration information, IP information, signals, spectrum analyzers, and graphs. All that stuff can be displayed on that, and just using this button here to cycle through. There is a difference in power consumption. I think it's a bit minimum, but that is just something to be aware of. Alternatively, they do recommend some antennas in the future. This is not currently available for the dual polarity functionality. So again, if you're buying the standard model of the TransNEXT, it has 2 radio ports, and this is for using dual polarity 900 megahertz antennas. If you're buying the standard version now, that currently is not available, so you can only still use the one, but eventually as a firmware release we will add in that secondary feature. I do believe, but don't quote me on this, that that's going to be an IP based system change, so that may not necessarily be applicable to the interoperability piece of the TransNet and TransNEXT compatibility. Now also there will be a light version which you may have seen at some point, or if you've looked at the manual already. we have been getting questions on that, and you can see that here. So this is basically just a single radio unit, no e-ink display, and this is going to be for your low power consumption solar, these sort of applications where you're maybe trying to minimize the consumption of the product, or you just have price points and a small budget, and you're just trying to keep costs low. The manual, like all of our manuals, will be improved on as features and things are released. There's a really good information in here. I highly recommend checking it out. It's not that long if you're used to seeing our Orbit manual. It's much less and much more specific to current releases. You will see, some of our typical manual layouts. We talk about, the transit networks, the interoperability, what that system looks like, and just sort of that migration strategy. We cover reports, pinouts, things like that. So appreciate you watching the video. Thanks for using GE, and feel free to reach out to BCI Technologies for any support questions. We cover the southeastern U.S., and that includes Florida, Georgia, Mississippi, Alabama, Tennessee, North and South Carolina. Thank you so much for watching. Have a great day.